This hand now serves as the reference design, which means it will correspond to any code that was used on this hand. In particular, it's worth having a quick look on how all the servos are arranged on the fingers. Here you can see the hand in the supine position. So this is the little finger, the ring finger, middle finger, and the first finger, 1, 2, 3, 4. And as you can see, all of the servos are arranged so that the servo horn is away from a finger, except for the middle finger. Middle finger is turned around, and that's to give some clearance for the thumb. And as a result of that, the wires on the furthest servo on the middle finger should be extended. And here I've done that by soldering in some short links. This one is also done, but that's just a repair. So it's not necessary when assembling. It's just this one that has to be done. You can also see that the way that the servos wind to pull in the tendon at the knuckles is symmetrical. This makes it easier to remember and also has a knock-on effect in the code. And later on, when we're looking at that, you can check quickly that things are set up correctly if you know that they should be symmetrical and they're not all slightly odd. So the way it's done here to maximize the clearances on how they wind up is that the near on the little and the first wind that way, and the near on the ring and the middle finger wind the opposite way. Down here, these also arranged symmetrically. Then we can look at the individual fingers that have been made up. If you've not already done it, now is a good time to clip on the tendon hanger. This clips into the forefinger just where the servos are screwed in the middle. Should just pop down. And it's secured on the underside with a small screw. On this finger, which is the first finger, the servo horn is away from the finger both times. It means the cable, the wire comes out the back. The middle finger is the opposite way round. On the middle finger, servo horn is near the finger. Servo's been turned over. That means that this cable, which is the furthest one, does need to be extended slightly. On the ring finger, again, servos are away. Where the power comes out of the servo is away from the finger on both of them. And also for the little finger, servo turns away. You look at a servo, horn can either be away from the fingers or it can be towards it. So for all except the middle finger, they are away. And those are the winding directions. And those are the winding directions. So that's what we need to pay attention to. And see that each pair is done as a mirror of the others. The thumb is very similar to the fingers in the way it's constructed. There's a figure 8 ligament which holds the tip, middle section, and knuckle section together. And it has 2 knuckle servos and 1 long tendon. Passes up through the middle of the basal joint. There is a difference, however, because the basal joint, unlike the fingers, has an extra rotation built in on purpose, and this allows the thumb to rotate. Now that is actuated by a spring here, which pulls the thumb in towards the palm and rotates it outwards because it's rotating the tip away from the palm, and a tendon here which rotates the finger inwards, putting it like so. That was done to improve the grip characteristics, but it's not exactly the same as the human setup. That is quite a simplification. Human setup has a good deal more muscles here and additional ligaments which control rotation. but on this finger this works pretty well. You can see the action there of the tendon to rotate the thumb inwards. The wrist joint holds together the hand and the forearm. And the distal pitch joint is in fact the joint which also holds the 4 proximal ends of the palm bones together. So just using anatomical terminology, distal means far from and proximal means near to. So the distal joint of the wrist connects to the proximal joint of the hand. In this case, it's made up of the 4 palm bones. On the proximal side of the wrist, it will connect to the distal side of the forearm. As a result, a lot of things have to happen at once, so it's easier if you do them in the correct order. A good example of that is the thumb, which has many attachments because it has 1 extra long tendon and 2 extension springs. When they're all in place, it's reasonably stable. The thumb will stay where you put it. When assembling it, however, this isn't the case, so it can be very annoying to have the thumb flapping around before everything's in position. So all we're going to do is prepare enough that the thumb can be assembled, but not actually attach the thumb yet. In particular, this means attaching the yaw part of the basal joint of the thumb, also known as the CMC, the carpometacarpal joint, which in the DexHand consists of 2 parts, a yaw section and a pitch section. These fit together with a bearing and then allow the thumb to rotate in yaw, in pitch, and also to rotate relative to each other. The yaw section is quite an awkward fit because in order to simplify the design, there's not a split here, it has to be flexed apart. The way to do this is to put a bearing into here, with your CMC, bit of stretching should go in, and then the top bearing can be put in from here. One other thing is that the yaw CMC, or the CMC yaw, gives the attachment for the extension spring which opens the thumb. The passive tendon, which extends the thumb, can be attached to a screw, goes into the top of the CMC, or is a separate insert, depending on how tightly everything fits into the extra height of the hole. Extra height, this is thick enough to take 2 bearings. As it's going to take an M2, I'm going to tap it, an M2 tap. If you don't have one of these, then it really shouldn't be difficult to force an M2 into that hole. If it is, let me know. I'll see if I can come up with any other way of doing it. It's very easy with a tap. And this will now happily take an M2. So the way that this is assembled, just push bearing into there. And that gives the extra axial rotation in the thumb. And now I'm going to pop that back out. Sure that's well seated. And now making sure that our screw hole is upwards. This is going to be a bit of a faff. Let's see if we can do this. So make sure that fits well and comes off okay. So that definitely fits on there. Not too much difficulty. Okay. If you have any problems with the fit, use 10mm drill. Loosen things off a bit. Bearing should just press in easily enough. Okay. Now this has to be stretched out enough to fit this. Make sure the hole is the right way up. And just brace against there. Push that open with your thumb until that drops into place. That will secure at that end. And then from above, take another bearing. Add a second bearing here and push them both in together. Make sure it's all lined up. With a bit of persuasion, that will push down. That will secure the yaw joint of the thumb. When the thumb is assembled, pitch can be pressed onto there. So it can be done. I'll show you how it goes. Okay. So this is the middle finger. With its one extended servo. Forefinger will go next to it like this. And the thumb will then go there. So you can start to see how the first few fingers come together. This is the ring finger, and that is the little finger. Now, the thumb can be put to one side. That will be attached later. So the last thing to do to prepare the fingers to be joined onto the wrist is to put the bearings into the proximal ends of the palm bone, into the proximal ends of the palm bones. Depending on how your printers come out, you might need to do a quick drill. So you want an 8mm drill. And just making sure that nothing gets accidentally caught. Just make sure those holes are open. As with any operation that could damage you, golden rule is always don't cut towards yourself. You're then going to need 5 3mm internal diameter by 8mm external diameter by 4mm thick by 4mm thick. And these are an easy fit onto an M3 cap head. At the proximal end of the wrist, there is a 60mm M3 cap head. And at the distal end, the bit which connects to the hand, there is a 70mm. That one is 60. That one is 70. They should just press in very easily now. On the middle finger, there is one on the other side which will support the thumb, whereas rather there's one which crosses over the first finger in order to support the thumb. the main thing is to make sure that everything is lined up straight before we start applying force. Otherwise you're just going to push the bearing at an angle. You've got to make sure that the pliers are about the right distance apart. Once you're square, it'll just go in easily enough. Okay. Take our 70mm cap head just to check everything fits. You can make sure that all the bearings are lined up. Into here. To here. That's the middle finger and the forefinger. The ring finger can be identified because it has a small proximal end. And for the first time we can see what it will look like with all the fingers. Now before that can be screwed together, the wrist parts have to be assembled. So let's take a look at the wrist.